Hello, everyone. Gaurav Dev back here from Scientific Dialogue. It is my honor to introduce our distinguished guest for today. He's none other than Dr. Sabieh Anwar. He's a renowned physicist, educator, and innovator who holds the prestigious position of Dean at the Syed Babar Ali School of Science and Engineering at LUMS. He did his PhD at the University of Oxford in the field of quantum computing, and I have been following him since quite a few years, ever since I started watching his lectures on quantum information available on YouTube. Highly recommended to all the students interested in this subject. He has had a remarkable career dedicated to advancing scientific education and research in Pakistan, and his contributions to the academic landscape of Pakistan are greatly appreciated. So, Dr. Sabi, how are you doing?
I'm fine, Alhamdulillah. Thank you for the very generous introduction.
Thank you, Dr. Sabi, for giving us the time. Dr. Sabi, I would like to start by talking about one of your amazing contributions, which was establishing Pakistan's first single photon quantum mechanics laboratory. Can you tell us more about that project in general?
In Pakistan, the teaching of physics is very poor, has traditionally been very poor, lots to be desired. In physics, when we talk about quantum physics, that's even more challenging. We can find classical physicists, people who are trained in traditional conventional physics, classical Newtonian physics, even atomic physics, laser physics. But when it comes to the intricacies of the quantum world, since it's a very confounding subject, a very counterintuitive subject, it has its own notation, it has its own paradoxes, and then you merge it with information theory, it becomes quantum information science. So all of these are new areas. Generally in Pakistan, the teaching of quantum mechanics has been shortchanged, which means we do not find many good teachers in quantum mechanics in our colleges and in our universities, though there are few notable exceptions. So I thought that I really wanted to teach quantum physics when I joined my institution, and so I took it upon me to teach quantum physics and learn quantum physics in the process. I also learned quantum physics on my own during my PhD and a little bit during my undergraduate studies, which was not in physics, by the way. So I was really interested about quantum physics, and what I liked about quantum physics was that its applications. I was really astounded by superconductivity, by lasers, by atoms, by spectroscopy. But when I started teaching quantum physics at my university, I thought that our students think that it's something which is locked in textbooks, which does not have a life outside textbooks. It's all abstract. People talk about Hilbert spaces, they talk about Hermitian operators, they talk about eigenvalues, and that's it. They do not see quantum physics, in other words. They read about it, they learn how to do the calculations, but they never see it. So seeing is believing, as you know. So, how can you educate someone in a subject without showing them the subject? So, I decided to show it to my students. And the best way, one of the most kind of straightforward ways to show quantum physics is by building a laboratory that materializes quantum concepts, and students can see firsthand with their own naked eyes how quantum physics unfolds in the real world. So I decided to build a laboratory which has now been established for 4 or 5 years. I, with the help of students from my own university as well as students from my own alma mater, Engineering University Lahore, we got together and developed this laboratory. So this laboratory is now one of its kind in the country. There are other institutions and organizations now that are following suit. They visit us all the time. They see our laboratories and they're replicating some of our experiments. So now this laboratory gives students an idea about what quantum physics is. They look at quantum states. They generate quantum states. They can generate entanglement. They can measure quantum states. They can transform quantum states, and they can look at the some of the very exciting and astounding properties of quantum physics, such as superposition, entanglement, and the baffling idea of non locality. So, all of this is on a tabletop. All year round students from our courses who opt for this stream. They can enter the lab and they can work with our researchers, with our lab instructors, and go through this suite of experiments. And finally, I thought that something good, if we do something good, it should not remain confined to ourselves. So we thought that we should now put it out in the public. So we wrote a book on it. So we now have a book which is called Single Photon Quantum Mechanics Laboratory, which is authored by myself and two of my students, Hamza Wasim, who's now pursuing a PhD at Oxford, and Faizan Ilahi, who was our master student. Now he's also hopefully going abroad for a PhD in physics. So the three of us got together and then we kind of put this in a book form. This book is now kind of widely recognized around the world, and it provides a blueprint to people around the world, especially in the developing countries, who would like to reproduce these experiments. So it has as much theory as is needed to do these experiments. So it introduces quantum mechanics, the notation of quantum mechanics, density matrices, entanglement, and so on. And then it, in a very refreshing manner, goes through how to build an experiment, what kind of techniques are needed to build it, what kind of measurements are expected, what kind of results emanate from those experiments, and then a thorough discussion of all of these experiments. So it provides a blueprint so that others can replicate it, especially in the developing world.
Dr. Sabi, as you mentioned that it can serve as a blueprint for other developing countries to follow. Can you please share what kind of resources, be it financial or be it intellectual, went into building this laboratory? Right.
It's not a very expensive laboratory. So, the very purpose of making such a laboratory of quantum physics is to do it at low cost. I would not say it's a shoestring budget, but it's not extravagantly expensive. So, any university in a reasonable developing world setting with adequate resources, which are not out of the world, these resources are not so extravagant as to become infeasible. So with these resources, one can replicate these laboratories, and you could do it in a phased fashion as well. You could do in a stepwise fashion. We while we develop laboratories, and this is not just the only laboratory that we've made hundreds of other different experiments. All of them have the hallmark of being low cost, indigenously developed from local resources. No imports are needed. With available resources, you can also do marvelous physics. So, and there are many ways in which you can save on costs. For example, there was a time when you need to buy very expensive electronics. Now, the electronics has been brought down in costs. There is a worldwide movement of which is called the open source hardware movement. It has democratized the availability of sensors, gadgets. We do all our electronics with a low cost field programmable gate array. In the process, our students learn about hardware descriptive languages, and they're also able to replace those expensive coincidence counting units with a low cost reconfigurable FPGA. So the costs are gradually coming down, and if you know the resources and if you have the will to build things, it's all the more possible. And by the way, we should realize that if you look at the physics literature that is going out, if you look at the best papers that are coming out in, say, the Best Physics Journal, for example, the Physical Review letters, the kind of phenomenon that are observed from the lens of a physicist, they're very simple phenomena. How do fluids mix with one another? How do droplets move around a corner? How does the wind blow and how does it impact trees? So these are very simple phenomena. Look at a burning candle, for example. uh, See how droplets spread, see how balloon inflates, deflates. So all of these are really, really simple phenomenon, but they carry rich physics. So I've seen this trend in the past 10, 20 years, where at the one hand you need super expensive smashing particle accelerators and these state of the art machines, and which are multi-million or sometimes multi-billion dollars in cost. But at the same time, with simple physics, with simple cameras, with simple gadgets, IoT devices, you could do remarkable physics. And so I've kind of liked this idea, and I've fallen in love with the idea of looking at simple phenomena, really simple phenomena that harbor deep, mysterious physics.
It is truly inspiring what you just mentioned, but what actually inspired you to delve into this field was the true applications of what you could do with, let's say, quantum computing, and especially looking at it with the lens of a developing country where we don't have such a booming high tech industry. How can it impact a developing country like Pakistan?
I think quantum computers, we are far behind as Pakistan. I cannot say this for other developing countries. India is also a developing country. Iran is a developing country. I cannot speak for them, but I can speak for countries like Pakistan. So we're far behind in the race for quantum computers. It's very hard to build a quantum computer and compete with the rest of the world. But what is possible is quantum entrepreneurship, for example. Quantum, quantum entrepreneurship means the building of small companies, small startups, spin offs, small units, research units, development units that work at some component in the quantum supply chain, uh, especially in areas of quantum sensing and quantum metrology. So, how do you measure ultra weak phenomena, ultra weak magnetic fields? How do you measure ultra sensitive light fluxes? Uh, how could you use quantum sensing for looking at minerals deep down under the earth? So this phenomenon, this technique of quantum metrology, quantum sensing, how could you look at biological signals, for example? Weak magnetoencephalographs, which are magnetic signals generated by the heart pumps pumping, or magnetic signals generated from neuronal impulses. How could you use quantum technologies to look at and measure and quantifiably measure these ultra feeble signals? So I think this is an area where developing countries can really make a mark. Building quantum single photon detectors, building quantum random number generators, uh, photon transmitters that could be used for cryptography. So I think the area of quantum entrepreneurship is very ripe for developing countries. Turkey is already taking a lead in this. So if you look at Turkey's physics industry, almost half of it at the moment is focusing on gadgets and tools and techniques which are quantum oriented. Then there's a huge quantum software industry. So, artificial intelligence, as you know, is now taking over the entire world. So, how do we marry artificial intelligence with quantum logic? So, there's a huge industry in quantum programming, using quantum techniques for financial physics, for financial forecasting. So, I think these are the areas where countries like Pakistan and the developing countries can really make an impact. But unlike other areas of entrepreneurship, which require a very strong engineering basic, this area would require a strong basic in physics, fundamental science, fundamental physics, fundamental mathematics. I think this is where the difference lies. So the edge is, and the catch is, to develop a human resource that is strongly grounded in fundamental physics, fundamental sciences. So it's not just a skill, it's also a new method of thinking. So programming is a skill, it's also a computational method of thinking, but it's more of a skill. uh, Once you get the hang of programming, software engineering, hang of programming, you get the experience. I think it comes naturally. But in order to excel in the field of quantum technologies, you really need to go deep down into the physics, develop the mathematical acumen, and then your skills will build upon those foundations. So that's where the key difference lies: the human resource development in basic sciences.
You mentioned a very, I mean, a good idea of quantum entrepreneurship. But to make this such an idea successful, there needs to be a role played by a lot of factors, right? It's not just the human capital; it's also the funding resources, it's also the market conditions, it's also about customer base, right? For any business to survive, there needs to be a customer, and because there's not a very robust high tech industry in Pakistan, who would be the customers of such, let's say, sensors or whatever technology or IPs developed by these companies?
First of all, the market for these technologies is not going to be Pakistan. The market for these technologies has to be regional and global. So I think we should break this notion that our products will should also remain in one only remain in one country. They have to be broad based, and they have to kind of get across and transcend geographic borders. The second point is, uh, there is one needs to create a market for this in Pakistan, and one needs to create the yearning and the craving for these technologies in certain sectors. For example, the defense sector, the military sector, and one sector that two sectors that I really want to mention, which have a great potential of kind of leapfrogging these ideas. One is space exploration, and the other is health tech. So if you look at space explorations, inevitably there is this growing emphasis on diverting resources in engineering, in physics, even in biology towards space. So coming up with life forms that can exist in extraterrestrial environments, making low cost spaceships, developing satellites at low cost, which can come up with new kinds of big data which everyone can then use for human benefit. Quantum technologies must have a big role to play in these space missions. Experiments that can be done over space, for example, micro sensing, gravity sensing experiments could be done using quantum technologies. Quantum technologies also rely heavily on optical spectroscopy, optical techniques, and optical sensing. Many of the traditional experiments can now be morphed into their quantum versions. So, space and health tech, as I mentioned earlier, they are areas where quantum technologies can really, really make an impact. In health tech, I've mentioned magnetoencephalography. They can make an impact in neuroscience, uh, and so on. In Pakistan, there's a vacuum of everything. There's nothing that really no high tech industry exists at the moment. So one of the goals of our academia would be not to liaise with the industry, because the industry doesn't exist. So this has been a misplaced expectation from our universities for the past 20 years. Collaboration with industry. Such a collaboration can never be done because there is no reciprocity within the industry. What I would say the universities should focus on is creating the human resource and the brain power that can make their own small industries. So one of the goals for every any academic institution in Pakistan, forward looking, progressive looking institution, would be to create the mindset so that our students can create their own industries. They can build new industries up from scratch. For quantum technologies, they would really need to have the human resource capabilities, and they need to have the laboratory experience during their 4 years of undergraduate education, so that at some point in time they get their hands onto real equipment, onto instruments. They can deal with photons, they can deal with ion traps, with atoms, with laser light. They can do spectroscopy. So this is really important so that they get the confidence that they can now go out on their own and start breaking new grounds and founding new ventures. At LUMS, what we've done in this direction is, we've kind of made our curriculum at the undergraduate level a quantum curriculum, so to say. I'm teaching a course right now on modern physics. Modern physics generally deals with kind of atoms and Compton effect and X-rays and Rutherford's experiment, Bohr's model, and these are all exciting stuff of historical importance. But I've really revamped this course, so now I teach quantum information in my modern physics class. I talk about beam splitters, interferometers, quantum interrogation, the quantum Zeno effect, quantum computers, quantum algorithms. That's what I'm talking about in a modern physics class. And these are students who just come into my modern physics class from an A level or an FSC background. So they are kind of beginners, but they're kind of enjoying this course. So all our courses are now geared towards quantum physics. And we've also launched a minor in quantum technology. So an engineering student, a biology student, a math student, a computer science student, the many computer science students like yourself who are now interested in courses on quantum physics, quantum mechanics, and quantum computing. So I think that's where our universities can make a huge difference, exciting and inciting computer science students, which form a major proportion of our student body at the moment, towards quantum technologies.
Dr. Sabi, what kind of feedback have you received so far on such courses? And I ask this from the perspective of a student. For a computer science student, quantum mechanics can be a difficult subject, right? How interested are they in this subject? And from a, let's say, a physics student perspective, there was a time when we from Pakistan, most of the places used to go into high energy physics or cosmology. Do you see that trend changing? Do you see a changing trend toward, let's say, fundamental quantum science research, or maybe more on the application side of quantum technology?
This paradigm shift hasn't been very widespread. In LUMS, certainly yes, because we have had the good fortune of finding the faculty who could teach these courses. Some of our faculty members in physics, they have re-engineered their own research interests. So they used to work on classical optics and modern optics. Now they work on quantum algorithms, quantum machine learning. So they've also steered their interests into this direction. For other institutions, I know of about, I would say, a dozen people in Pakistan, one dozen, who are trained and well versed in quantum information sciences and theory, not on the technology side though, but they know about quantum optics. Quantum optics has been very popular in Pakistan, and that has been due to one luminary in quantum optics. His name is Professor Sohail Zuberi. Professor Sohail Zuberi was a professor at Qaid Azam University for many years in electronics, and he pioneered the field of quantum optics in Pakistan. He himself was a student of another distinguished quantum optical physicist, Scully. Now he's a professor at Texas A&M University. He's a distinguished professor there. And now he's found interest. He writes about cosmology. He writes popular books on quantum physics as well. His, his recent book is The Mysterious Universe. So this one person has kind of triggered an interest in quantum optics in the country. But all in all, there would be about 12 people in Pakistani universities who do quantum information sciences, quantum information technology. There's some in Karachi, some in Lahore, most of them in Islamabad. There are some research organizations within the defense sector, strategic sector, who are developing quantum technologies. They have made atomic clocks. They are also making a single photon laboratory. They do other neat quantum experiments. So I think it's growing slowly, but what we need at the moment is a push from the government. There are ideas to set up a national center for quantum computing, but the government has really not been up to it, hasn't acted like a government that wants to support knowledge creation so far.
Nuclear project was also one of the projects supported by the government itself, right? What was different at that time?
I think what's different right now is that we've uh, lost out on, on the recognition that knowledge creation is important. So the past 10-15 years have been really marred by political bickering. They have been really, we've gone through tumultuous times politically. Uh, Recently, the past 3 or 4 years, we are seeing our lowest moments in terms of freedom of expression, freedom of thought, creativity. Our universities are not getting any funding. Uh, Development of science, development of technology is nowhere on the government's agenda. Not even the lip service exists at the moment. So I think we've lost out on this. The nuclear program was indeed one of the reasons for the success of the nuclear program. Of course, there was the goal, there was the motivation that one of our neighboring countries has a nuclear program. We should also follow suit and we should compete with them in that respect. And as Zulfikar Bhutto said, हम घास खा लेंगे लेकिन बम बनाएंगे. लेकिन at the same time, uh, the one of the reasons of the success of the nuclear program, I think, was self-governance. Self-governance means the scientists and the engineers, they made the decision. They made the decision of how to do it. They made the decision of when to do it. They made the decision of what resources would it needed, and they commanded the resources. They decided how to buy, when to buy, from whom to buy, how to build, when to build, and who will build. So they were the silent warriors. Now it's not the case. The scientists are now not governing their own activity. Their activity is now governed by other players in the country. So I think it's very important that we reinstate in the scientists and engineers of this country, and there are thousands of engineers and scientists in the country at the moment, reinstate in them the confidence that they have the space to create. Another example is a space mission. Look at look at space exploration. Space exploration is inextricably linked with our security, not just geographic security, but also food security, climate security. So without geospatial mapping of our agricultural resources, which requires space technologies, which requires satellite mapping, geographic information systems, it's impossible to kind of cultivate our huge areas of land. It's impossible to irrigate, and it's impossible to control our climate and our weather, which is creating havoc in the country at the moment. Just imagine the air pollution problem. How could you solve the air pollution problem without mapping where the pollution is coming from? How does it exist? So without space, space is anything above the ground. So without space exploration, it's hard to think about security. So I think we need stable governments, seasoned leadership, which is some areas in the country need to be insulated from politics. Science and technology is one of them. And I think our governments have failed us in that respect. And no matter how hard private institutions like LUMS and others could do, they are only an iota in the big scheme of things. They're only a drop in the ocean. These moonshot projects, as you mentioned very early on, require government support. They can't go without it. And government support is also needed for basic education. Who will get into these projects? Who are the engineers? Who are the scientists who will learn quantum technologies? Only students from the elite schools who, if they cannot get into LAMS, or the first choice is going abroad and they will never come back to Pakistan. India's Chandrayaan mission was all engineered and designed and developed by people who were trained by their IITs. They were indigenous, homegrown scientists and engineers. So we need the government to at least do a decent public schooling system, which is free for all, which is the same for all, which has a single curriculum for all, and where students can, from all nooks and corners of the country, can go and learn and do exciting science and physics, and their minds can be opened up. So that's the role of the government. Without that, this will remain a dream, I think.
Hmm. Dr. Sabi, just towards the end, I do want to, maybe share some hope and optimism for a student in Pakistan, and not just for the sake of it. Do you think as a sensible approach for a student today would be to aim for the best, research projects to work on and get sort of an international exposure, and then, maybe foster these kind of projects in Pakistan?
So one of the slogans in Pakistan, roti kapda makan. So food, shelter, clothing. So these are demands from the people. I think one needs to create a demand for quality education. There has to be a fourth pillar in this slogan as well. Yaksa और अच्छी तालीम सबके लिए. So I think the students need to create this demand. Nature abhors vacuums, which means nature does not like vacuums. So there is a vacuum in Pakistan in almost all disciplines. You want to mine coal from the country, you cannot find trained mining engineers, trained miners. You want to dig out copper and silver, and you want to separate copper from silver from the mines in Balochistan. You do not have the human resource that is capable of doing that. So it's really important. There's such a big vacuum in all of these disciplines. Students should demand quality education, or it has to be in the political manifestos of our political parties. No political party in the country at the moment really has made it a point to include quality education in their manifestos. No political party has given any importance to science and technology and knowledge creation, and the resources that are needed in this direction to be a certain proportion of the GDP. No one has ever done that. So I think it has to be a political slogan. The political slogan has to come from the masses. So as far as individual students are concerned, like yourself and I consider myself to be a student, we as individuals really need to emphasize on quality. We should not be, sorry to say, uh, when we want to do something deep, we should not be lulled by distractions. Sometimes social media can be a distraction, sometimes shortcuts can be a distraction. uh, we really need to go deep into at least one or two branches of knowledge that we seek to learn, and we should demand it from our teachers. We should ask our teachers, as in our universities, to give us more. Ask them to give us more. And the other thing that can really help is to make the teaching profession, the university, the academia more lucrative. Currently, if you look at our salary structures in our universities, it's dismal. Technicians don't get paid anything. It's a highly deglorified and a base kind of work. Technicians and building people who build things.
Yeah.
So I think there's a lot to be done, but creating the demand for education has to be an individual demand, it has to be a group demand, it has to be a community demand, and above all, it has to be a political demand.
Revolution is sometimes better than evolution.
Revolution led by the most sincere people, but it's very hard in this time and age to come up with a revolution, I think, that really is going to work for the ultimate better. We haven't seen such a revolution so far. Chinese transformation has been kind of steady. It's not really a revolution, it's a very fast paced massive evolution, engineered evolution that has taken place. You can see this engineered evolution taking place in many some far eastern countries. Indonesia, for example,
Yeah.
is one example. Bangladesh might be another example. So I think revolution is not the answer at the moment. The Arab Spring was poised to be one such revolution, but unfortunately it kind of failed. That would have been really something.
Do you think a way forward would be to maybe have sort of a regional approach for developing this technology?
I think it's a very good question. Unfortunately, over the since 7th of October, I think that my kind of pan regionalism of this nature has really gone down the doldrums because what we see in the world at the moment in the Middle East right now is a kind of unprecedented scale massacre. So, and this was the time for countries to get together and kind of come up with a unified stance against aggression, but they didn't, unfortunately. So, I do not really have hopes with the monarchical rules that already exist in these regions. But what I think is really important and an untapped region in the world is East Africa. So if you look at the year 2040 or 2050, 60 to 70% of the world's cosmopolitan centers, urban cosmopolitan centers, will be in East Africa. I think that is where the future expansion should be done. And that is where Pakistan should really focus into, develop stronger ties with East Africa. They are going to be the new regional powerhouses of resources and knowledge creation, I think. So this is where we should look at.
Very interesting. Thank you so much, Dr. Sabi, for sharing that so many insights and giving us as students the hope and maybe directing us in the maybe showing us the right direction. So thank you so much for the time and really appreciate it. Thank you.
Thank you, Gaurav.